Hi, good morning, everyone. Requesting everyone to please get settled down as we are starting in next 2 minutes. Good morning, everyone. Welcome back to the last and final day of Trafotech Global 2025. We have some very interesting sessions lined up for half a day today. So let's start the day with the keynote address by Professor Angelo Baghini. Dr. Angelo Baghini is a professor of electrical engineering at University of Bergamo and international consultant in energy sector. He has significantly contributed to the development of Indian standard IS 17036-2018 and has authored over 200 technical and scientific papers in national and international conferences. Due to some flight-related issues, he is unable to join us physically today, but he was very kind to present his technical keynote address virtually. So over to you, Dr. Baghini.
Thank you. Just confirm me, you are hearing well?
Yes, we can hear you.
Great.
Thank you.
Thank you very much. Let me try to share my screen. I can share. I am not allowed. By the way, I don't need really to share because in my opinion, okay, okay, now I am allowed and I should have to see my screen. Correct? Great. Thank you very much, distinguished guests, colleagues, ladies and gentlemen. It's really a great pleasure and an honor for me to be here with you today. Unfortunately, the initial plan was to be together physically, but some troubles changed my plan. In this moment, I believe that we are in front of a truly transformative moment for our entire industry. The power transformer sector is indeed a mature sector in a stable field, but now it is entering in a period of profound change. Several changes are converging, and they will reshape not only the way in which we design transformer, but also how we regulate them, how we supply them, and how we integrate them into tomorrow's power systems. Let me highlight a few of these changes, obviously in the perspective I have. First, we are witnessing new and competing technologies that perhaps in the future, not yet ready, they will be capable of delivering the transformer function with way, very different way from today's conventional design. Second, new form of generations, distributed generation, renewable storage system, DC grids, and so on. That will need to be operated and managed in a different way. Third, users and legislators around the world are showing an increasing interest in new categories of transformer performances. For the time being, energy efficiency. Fourth, honest, frankly, 8 years ago I sold, and I also convinced ICTC 14 that there is something very simple, but something philosophical, but with a strategic importance. That is the power transformer definition itself. At the time being, it is here since many years. The definition of power transformer is a static apparatus with two or more windings, which by electromagnetic induction transforms a system of alternating and current into another system of voltage and current at the same frequency. This definition has served us well, but it has also introduced several limitations. Here I reproduced the regulation, two articles of the European regulation and the United States one, simply because I don't have the equivalent of one in India. Indeed, and let me say also appropriately, this definition has been adopted identically by various regulations that have been established and continue to impose, for example, minimum energy performance requirements. This regulation reflects the function of a power transformer, but it is referred to a specific technology used to realize that function. That in fact is the only one available today practically, except with very few experiments. And then this implicitly excludes alternative technologies capable of delivering the same function. This means that any technology not based on electromagnetic induction would automatically fall outside the scope of regulation as well as outside the scope of TC14, and therefore outside the performance requirements and obligations that apply to conventional transformers. As a result, innovative technologies have been prevented from entering in the same regulatory framework, creating the risk of unfair competition, first of all, lower compliance cost for these new technologies, and a reduction in the environmental and safety benefits that current regulation aims to deliver. Indeed, in the perspective of manufacturers, regulation are adding a significant cost and complexity. If new technologies providing the same function fall outside the definition, they will also fall outside these requirements, thus distorting the market and undermining policy objectives. Then there was, because this is partially done, the need to revise the power transformer definition itself, to avoiding any reference to the actual basic technologies. Thus, to be able to set up some key waypoint for future standardization and regulation development, with the final target to be ready to manage properly the mentioned changes. Then we worked on a fully functional definition of power transformer. We know from the past experience that definitions matter. They matter in standardization, they matter in regulation, and they even matter in policy making. An interesting example outside because the design was fixed by regulation. We shaped a new functional definition of power transformer. Now, a power transformer is a transformer with the purpose of transmitting electrical power. With the rules in IC substituting the different names used in the definition, that is transformer that is using converter, converter that is using alternating voltage and current, the definition, the full definition sounds like this one. AC, electric energy device for changing one or more characteristics associated with electrical energy without moving part that changes voltages and currents associated with electrical energy without change of frequency, with the purpose of transmitting electrical power. I think that this is a small step, but essential for to leave the floor for future development. And in fact, this is fully in line with the main goal, the main target of standardization. This aligns with the principle established in the ISO IC directive of providing a framework for future technological development and of performance and to setting performance-based requirements. Whenever possible, requirements shall be expressed in terms of performance rather than design or descriptive characteristics. This is not a minor detail. It represents a foundation for future standardization and regulation, one that will allow us to accommodate new technologies, new application, new performance needs without distorting the market or compromising safety, sustainability, and functionality. But this is not enough to be concrete. The category of power transformer is a characterization class in the language of standardization. This first level of characterization is further detailed or needs to be further detailed by means of some property value pairs, which describe more precisely the target product within its characterization class. And here, in my opinion, that is, let me repeat again, in the perspective of regulation and standardization, are the other changes we have to manage. Let's say, behind energy performance, new dimension of ratings. Actually, today, requirements of power transformer are differentiated both by standards and legislations according to ratings, technologies, and applications. In the past century, virtually all transformer ratings were related to safety, service performance, and similar aspects. Losses were mentioned, but were mentioned almost exclusively because they were the source of thermal stresses on insulation, not because of other reason. In the last 20 years, we have effectively added energy performance to the list of ratings, even if at the beginning energy efficiency, I prefer energy performance, was not called a rating, but at the end it is a new rating. In my opinion, in the coming years, we will likely consider additional performance categories on the same level as the traditional ones. That is, we will add other ratings to our power transformers. and basically all of them will be linked to the environment. Environmental performance that is will no longer limited to energy efficiency, energy performance alone. We are entering in the era of material efficiency. Material efficiency will play a crucial role, including durability and reliability, remanufacturability, reparability, reusability, upgradability, recyclability and recoverability of materials, proportion of reused components, recycled components, and the responsible use of critical raw materials. These dimensions, in my opinion, will shape the next generation of power transformer standards and will guide the industry's sustainable transition. Trying to conclude, ladies and gentlemen, our sector is undergoing a deep transformation. By adopting a function-based, technology-neutral definition of power transformer, this is done. It's only matter to wait for bureaucratic time. We are preparing the ground for fair competition, innovation, and effective regulation. Adding new categories of ratings, we will enable the industry to respond constructively to challenges of new environmental expectation and new performance requirements from both user and policy maker. This evolution will not only protect the integrity of our market, it will also allow us to fully embrace the remarkable innovation that are waiting just behind the horizon. I am confident that working together, we will ensure that power transformer, whatever technologies they may use in the future, continue to play their essential role at the heart of a reliable, efficient, and sustainable power system. That's all from my side. Thank you for your attention. It's really an honor to share this thought and this moment with you. Thank you.
Thank you, Professor Baghini, for the address. Now I would
Welcome.
request Shri LKS Rathore to present his paper on digitalization and automation of power transformers, cybersecurity challenges and mitigation. Shri Rathore has over 13 years of experience in Western Region Power Grid Operation, and he is currently serving as the Director of Cybersecurity in CEA. Can we have a round of applause for Sir?
Very good morning to one and all. Thank you, IEEMA, to give me a chance for the spreading my field in this Transformer Manufacturers Association. Basically, most of the people, so you are maybe tired since last 2 days. You are learning, but this is the special topic which may you not be expected that whether what cyber security in the transformer and what should be the change, what are the role of the cyber security in the transformer. That portion I try to address today. Again, thanks to the IEEMA. Basically, my topic is the digitization and automation of power transformer. As you are already aware, when we are slide change by this one. Okay. When we are seeing the power system, the transformer is the very important element, and the quality of the transformer and the associated accessories along with the transformer, which make it very useful in our power system as on today. But if you see, the transformer almost cover the 30 to 40% of our whole power system, right from the generation to the hand. Whatever we have the adapter, where also we have the transformer. I am not talking about the only power transformer. Every person who have the mobile, they have the transformer. Means that transformer which are the big size is the convert into the, you can say, the palm size transformer, and that cover, it may be changed if the some cyber security incidents happening, your adapter may be blast, because some chips are there in that one, and if that chip manage the parameter or the manipulate your parameter, that may be cause of the blasting of the transformer. I am just starting my presentation with the small used case happened in the USA in 2020, where one of the power transformer blasted, and when someone analyzed that one, it was found that there is some embedded chips malware were there, and that manipulate the parameter of the transformer, just like suppose the transformer is operated at the 90 degree, otherwise the 70 degree, and because of that embedded chip, if you manipulate the sensor of the temperature sensor, the limit can be changed to the 160 degree, 170 degree. Even the transformer is loaded and the temperature is across the 90 degree, or the 100 degree, or the 120 degree, the transformer is a sense it is looking like a 60 degree, 50 degree, because of the manipulation done by the encryption from the other side who having your control. It means what? The chips which is embedded there, it change your basic functioning of the transformer is the function. Transformer is the passive device. You can say the electrically active, magnetically active. The transformer box is the passive device, container is the passive, copper is the passive, but the signal which is used for the monitoring of the whole transformer, operation of the transformer, that can be change, and finally that leads to the heating of the transformer, which is not detected by the fellow who is monitoring the transformer, and that leads the blasting of the transformer. Once the transformer blasts, you can say that the substation may be get disturbed. Finally, if that is the critical substation, then the grid may disturb, and it may be lead to the cascading of our power system. That may be the financial loss and the commercial loss in our whole economic system. So here, you can say whatever here I put it, the 30 to 40%. It means what? Right from the power to the handhold transformer. That what we call the adapter. Next, then anything happening in the transformer, that will be the really loss of the whole power system as well as the economy of the. It is nothing but in my opinion, it is the backbone. Right from you can say generator, then the transmission level, then the distribution level, then our utilization level. Everywhere transformer is there. It is the important part of the life. Right now we are going to making our grid is the smart grid. So the automation and the digitization is the very important thing. That is in process. For that one, we need to the sensor, we need to the control from the other side. The signal will be transferred. Someone can be detect. Now that detector, the sensor, if it is manipulated by someone from the manufacturer, intended or unintended, then that will be lead to the abnormality of the transformer. Finally, it may be disturb our power system. So there are the many chances where the cyber attacks can be happen. Again, I repeat. Transformer, when we are talking about the transformer, even the transformer manufacturers are here, we are just telling that yes, transformer is the big one tanker, that iron tanker, and then the inside CRGO materials are there, then the coils are there, what thing happening? Even, maybe most of you will listen that, the radio interference, what is that radio interference? Because of the electricity line, 50 Hz is interrupted to our telephonic line. The magnetic induction, the electrostatic induction, that can be affect that one. Here also the huge magnetic induction takes place during the transformation of the power from the one circuit to the another circuit, but it is the within the core. The most of the that flux are the bounded in the core. Small amount, 0.01% is the that is the leakage flux. Otherwise, the whole flux is the transfer to almost 99% flux is transferred to the secondary side, convert into that one, and it will be the accordingly that depending on the number of turns and other things, the voltage and the XDA, their parameter XRL and other things are the change. But the same thing, if anyone can be suppose embedded something and try to change that flux from the outside, then whatever the actually that can be different, and the monitor, the people who is the monitoring their parameters, who see in the different different you can say the temperature is different, the flux level is different, you can say the DGA level, that is also that may be the different. That's cyber challenges in the transformer when we make it is the automation. But automation is equally important than today. Automation the welcome, the new technology always the welcome. We welcome the automation and digitization of the transformer, that will helpful to the finally automation of our whole grid, and we can be sophisticated operate our grid. But at the same time, we are the according alerted, so that you can say the grid should not be disturbed because of the transformer. Here, what are the cyber risk? I again highlighted DGA, where the sensors are there. If sensors are there, that sensor can be transmit just like our CCTV. What is CCTV? Which we can see in our this mobile thing, that what is going on in my house, or what our maid is doing, that we can be see here. Similar, how it is possible? That is through the app. If some sensors are there which can be transfer the signal, if it is embedded on the transformer, any part of the transformer, even the tank during the assembling, even in between the coil, even it is the within their associated equipment like the DGA sensor, like the temperature sensor, other sensors are there. Then that the signal transferred to the SCADA, HMI, that will be the maybe the false type of incorrect parameters, and accordingly the operator will take the decision, and finally it will lead to the problems in the transformer. So these are the inside component, where I just want to say that where the sensors are there particularly, there are two things. First one is that during the manufacturing intentionally, if suppose some of the prior reference countries who want to disturb the India, they put some chips inside the transformer during the manufacturing itself, then there will be the problem. So that should be the properly FATE should be the properly done by our FATE peoples. I mean the factory acceptance, we had to be go there, and as per the design, is there any additional components are there or not, that has to be verified. At the same time, the set is also the equally important at their commissioning stage, where the actual transformer whatever we want, it is the as per the requirement, or some additional features are the added in the transformer, which maybe they manipulate the data of the transformer to their end, and that will be the danger for the operation of the transformer. Again, I repeat that one. What is the challenges? If it is the signal, if there is the signal, if it is dedicated type of signal, the chances of cyber attacks are the least. But if it is the internet exposed, internet exposed system means anyone can be enter in their system, and then they can be simply write the inscript and finally change the parameter, and accordingly they can control your system. Because you are the industry people who are generally on the transformer side, maybe you are this is surprising for you, but we as a director of incident response, I make at least 130 incidents within this last 1 year, and so many incidences where the people are simply embedded the chips. Particularly the higher management people, generally what happens when there is the higher management people, they are their son and they all they are the well settled, and he and his wife is there in the home, and most of the 90% time their home is the only vacant. So what they are putting the camera, that camera having the chips, and that chips can be transferred to the information to the other thing. So here also in surveillance case also, in our transfer substation even also, the peripheral device also we can be, if are putting the in CCTV, that is also the problem. So here I am just highlighting that supply chain and firmware threat, this is another risk for the transformer. That real world key use case I already explained. This may be happening if you are not alert to manufacturing, to the commissioning stage, to the transporting stage, even if during the supply also, the something can be tampered, so we are the equally alert during the whole process, whole chain process of the transformer. Then that the false data injection attacks is what? Simply you can, if it is there is some sensor which can be the transfer the signal, it can be manipulated. So that is another type, and you can say that as on 2-3 days before that GPF spoofing is there, that will totally interrupt our this aviation sector. So it may be happening because of the geolocations and all these things are mapped by our telemetered, means the grid operators. So if something is the change, location is changed, at the time stamping is changed, its operation will be also the get affected. So that the DDoS attacks, denial of service, that the distributed denial of service, that may be also change within the transformer parameters. What the government is taking right now. In short, I am just explaining that, I am just informing you, the government of India is the very serious, particularly in the Ministry of Power, where the special orders were the issued in the 2020 and 21, when there is any imported component, even if it is the indigenous component, properly fed and a set has to be there. If any component is simply put it in the power system and it is not properly cyber check, digitally check, only the electrical parameters are the verify earthing and the other electrical safety parameters are they looking on, then it may be lead to the disaster because of the cyber threats. So that is what the Ministry of Power issued the guideline. Initially it was issued for the component level, whatever the component, especially for the sensor device, RTU, FRTU, as well as the wherever with the sensor, even in the transformer also, DGA sensor, where the ppm level can be seen. Apart from that, the temperature sensors, the pressure sensor, if that sensors are the imported from any part, but particularly from the prior reference country, that has to be checked. Although I agree that we have not having much more testing capability, but the sample testing has to be there. At least there are the thousands of transformers, 5% something testing has to be there, and accordingly we can be decide this component is the useful for, this can be embedded in our grid system. Then another change was there in 2025 because of the testing strength was not up to mark as on today. We as the Ministry of Power that change that order as a device form, not the component form. So as a whole, this is support device. There are so many components, but this device is testing instead of the component level. Component is a very critical type. So there are so many testings are there. If it is these are the thousands of the components. So similarly, transformer is the more than 10 to 15 components are there. Sensor level components are there. So instead of the testing each and every components, there are the it has to be the transformer as a whole. Testing is there, and either the transformer or their sensors or the associate device that has to be tested, and it has to be cyber compliance. Then the communication system regulation BAP CA 2020 also stress on the cyber as well as the communication protocol. Then another very big achievement of the Ministry of Power that set up the CSET power, and this CSET power is the especially, I am the director there, I was the director there recently, yesterday only I got the promotion and joined as a Chief Engineer Regulatory Affairs. So before that, I was working since 3-4 years, and this CSAT power is the one of the first civilian sector sectoral CERT. Actually, the cyber security is the subject of the mighty. CERT is the looking after the cyber frauds and the cyber threats in the whole India. But in 2013, because of the so many sectors are there, including the railway, finance, telecom, communication, everything, the sectoral CERT concept came, and the first sectoral CERT is in the form of the CSAT power at a Ministry of Power, that is the Katwaria Sarai, which having this much mandate work, incidence analysis along with this one. So we are the not only looking the regulation and the compliance one, whether the components in the grid, in the power system, those are the integrated, that is the equally looked after by the CSAT power at a different level, right from the generator to the DISCOM, and even the DGR, the distributed renewable generators. They are also you can say the rooftop solars. We have the right now. You can say the 23 gigawatt is on today we have rooftop. The rooftop, most of the rooftop sensors and the inverters, they are imported. Here generally we are assembling that one. So the components who are there and which is with any country, they can be controlled over 23 gigawatt. Suppose 23 gigawatt, when at daytime something happening, our grid fail, all the DGR, the rooftop solars are simply off. Then what happen? Our whole grid will be get affected. So we are also looking after that one. These are the functions mandatory to given to the CSAT power. Apart from that one, drafted regulation, we again thanks to the IEEMA, they have commented so many things, and yesterday I sent that regulation to the authority because the regulatory affair division is the only division who is the custodian of all the regulation of the CA. So yesterday evening I forwarded to the authority for that approval. Then the trusted vendor system. The trusted vendor system is what? It is in line with the trusted telecom gear. In trusted telecom gear, the trusted source and the trusted product, from where we have to be purchase the material and which product has to be purchased. So there is some criteria where any vendors will be, suppose want to sell some product, the product has also be have the criteria that has to be satisfied, then it can be purchased further, it can be integrated in the power system. Similarly, similar to that, from which vendor we have to purchase, so they have to be also registered in the trusted vendor system. So this is nothing but the control of the supply chain, where the chances of the embedded malware will be there. Then proper audit is a very important thing that the Ministry of Power is the stress on that one. Generally what happen when any material procured, commission, and finally before charging and it will charge, then the audit process is very weak in our Indian system. So the audit is the one very important parameter. If it is the thoroughly and a comprehensive audit, the almost whatever with the lacunas are there, that can be point out and it can be solved. Most of the practical life we can see that yes, the audit is there, the certificate is given at the hotel only. The auditors came and he will give the 3 days, 4 days audit and the points of okay, it is all compliance. So if it is this type of audits are there, it will be very difficult. The Ministry of Power is highly concerned about that one, and the scope of the audit guideline that is issued and which has to be followed by all the utility in our power system. Then cyber security guideline already issued in 2021. You can see the promptness of the CA when there was our India is not only India, the globe is suffer with the corona. The CA people are preparing the cyber security guideline, because of at that time only we changed from the physical to the cyber world. Mostly most of the work is done in the digital form from the home also. Then another thing is we are also conducting so many awareness programs as well as the regional workshop as part of the capacity building. We are collaborated with the IIT Kanpur, IIT Kharagpur, RRU Gandhinagar, as well as IISc Bangalore, where we framed that tailor-made program for the power system. So where even if the transformer industry want to take the training, tailor-made program will be made, and we have the emulated system at the IIT Kanpur also, as well as the IISc Bangalore also, RRU also, where the hands-on training is there. It is not the PPT type of training, where the 5 days, 6 day type of training is there, and we get the certificate. Not like that. They have to do by their own, then they can be able to control the cyber threats. Another thing is how we can make the incidence response, and also we have the forensic lab where the forensic images are there, and we can do the any type of cyber incident where the some images are there. This can be controlled by the and find out the root cause of that incidents. So again I repeat, there are the more than 30 incidences where the analyze along with the forensic analysis also done. Forensic analysis is we are sending the forensic analysis for the any incidents only when there is some big repercussions are there. Otherwise the analysis team, we have the cutting edge technology tools as well as the software, and 24/7 associate our CSAT power. So it is a continuously operating like the NLDC. So that is there, and the cyber defense people are sitting there, and they will be managing the incidents in the whole sector. Final conclusion is that digitization is the welcome. Even the transformer digitization, even the online DGA and everything, we are controlling from the other side. That is the welcome to our technology. Always the technology is welcome, but at the same time, the cyber risk and the cyber threat is equally important. That mitigation, that precaution we have to take to control any cyber threats. Another thing is the cyber physical assets are there along with this transformer that has to be properly take care. The IEDs and the communication interface from the transformer associates to the SCADA, that should be also the communication channel is equally, if it is properly encrypted, then okay. Otherwise, you can see in one of the picture when the Govinda call to the Lalu Prasad Yadav, so he told that who Kalu Mausa Kalu Mausa, so he told that ho कौन बोला रे, तो बोला मैं कालू बोल रहा हूँ. That is, he is sitting in the top of the pole, and that is what he tends to transfer the message from the one point to the other point. But the made in middle, that is called the made in middle. Your communication has to be go from the one point to the another point. But in the middle portion, there can be the change in your information, and the final information cannot be reached to the destination. That is similarly the adversary in the middle is also there. Finally, I request to all the manufacturer and the transformer associated with the transformer industry, please adopt the zero trust model. You are the key role player in our sector. Whatever you are manufacturing, that has to be the cyber resilience also at your factory, during the transmission, and finally during the commission. This is the responsibility of the owner of the installation. Thank you very much. Viksit Bharat and Cyber Secure Bharat. Thank you very much.
Thank you, sir, for such an insightful presentation, and many congratulations on your promotion from the entire gathering, sir. Now I would request Mr. Nagarjuna Babu to felicitate Shri Rathore. Thank you, sir. Now we are having a special address on South African market demand for transmission equipments and components. And for that, I would request Mr. Mark Goliath from Industrial Development Corporation to be on the dais. Mr. Goliath is the acting divisional executive of the Industrial Development Corporation, which is IDC. IDC is a development finance institute owned by the South African government and is a key player in facilitating the upgrade of the South African transmission grid. Over to you, Mr. Goliath. Thank you.
Yeah. Good morning, everyone. Unlike your other presenters this morning, I won't be very technical. I think IEEMA took advantage of me being present and decided that maybe I should just give an overview of what's transpiring in South Africa, especially to the new transmission rollout. Thank you very much for the very brief introduction. And the Industrial Development Corporation indeed is a state-owned bank in many respects. And with that in mind, a key implementer of government policy. And the new government direction is really focused on a transmission line rollout, which South Africa hasn't embarked on for many years. I mean, over the last 15 years, up until 2018, South Africa only brought online an additional 4,000 kilometers of transmission. And it's one of the really inhibiting factors to power security within South Africa at the moment. South Africa has just kind of brought on board a new integrated resource plan which looks at bringing online about 50 gigawatts of electricity over the next 12 years. But one of the significant inhibiting factors to that is that as a country, we do not have enough transmission capacity. In fact, as we speak at the moment, we've got quite approximately 10 gigawatts of energy that is in build that we cannot absorb into our network because we don't have the transmission capacity. So hence there is urgency around bringing the transmission line rollout to fruition. The ambition of the Ministry of Electricity and Energy in South Africa is to bring on board 14,500 kilometers of new transmission capability in the country, linking new parts of the country into the grid. And with that comes the realization that we don't have the necessary value chains within the country to support that. We've got extremely limited capability in transformers, especially on the class 3B transformers within the country, which, with the build in mind, we're going to require approximately 180 units over the period. Now, this does pose an opportunity. South Africa's focus, like India's, remains on localizing as much of our value chain manufacturing capability as possible. We have not been successful in other areas, but the government is committed to use this 25 billion rand, or $1 billion spend, sorry, so used to speaking in rands, $25 billion spend over the next 10 years to really deepen our value chain opportunity with transmission, transformers, insulators, and surge arresters, because these items are not common for manufacturing and is currently being imported into the country. So the government does see it as an opportunity to deepen these value chains and bring on board strategic partners who are looking to set up manufacturing capability within South Africa to support this. We are in phase 1 of this rollout, and phase one looks at installing approximately 1,100 kilometers of new transmission line and all the associated requirements that go alongside that. The request for RFPs will be closing in July 2026 for this rollout. And hence it's important that we gain traction on this. The colleagues from IEEMA have been instrumental in supporting the South African government, because one of the key elements that we are looking for at present is the lessons learned from countries such as yourself who have gone through this. We're trying to understand how you deepened your value chains, how you looked at localizing elements that were core to your transmission rollout, because there are no new problems in the world, or very few new problems in the world. And part of the discussions that myself and my two colleagues will be having over the next few days with our local counterparts is, how do we learn from yourselves? How do we utilize the insights that you've gathered over the years so that we can take that home and support our Ministry of Energy to ensure that we try and put a framework in place which really focuses on trying to maximize the local manufacturing opportunities within a South African context. We are very open. We will not use a negative. We are very open to bringing on board interested parties, international players in manufacturing. There are significant gaps within our value chain that we would like to localize, and that's the opportunity that the 25 billion rand infrastructure project, $1 billion infrastructure project has. The fact that it is a 10-year horizon does create opportunity, because there is an amortization of cost or a project return to anybody who is looking to set up within South Africa that can be highlighted. We're also very keen to utilize the skills that we are developing within South Africa through this process for the rest of Africa, especially sub-Saharan Africa, and especially the South African development countries, which are our more immediate neighbors, where electricity rollout or energy rollout remains a key element. It is no secret that Africa still remains hugely under-resourced for energy, and it's an inhibitor for industrialization. So with that being said, we are very keen to utilize this opportunity to its fullest. For those that are not aware, our energy supplier in South Africa, Eskom, and has been the sole supplier of energy or baseload energy into the country for many years as a state-owned entity, has been split into two. It's now divided into generation and transmission. The transmission element is independent and is now controlled by, or under the auspices of, the National Transmission Company. And that's who the IDC at this point in time is supporting. We are really collaborating with them to see how we as a development finance institution support the establishment of manufacturing capacity, but not only support the establishment of new manufacturing capacity, support established manufacturers to ensure that they have the right capacity and capabilities to unlock this $25 billion opportunity over the next 10 years. So it is an exciting period that South Africa is entering. I think it's the first kind of step in really trying to secure our electricity supply and deepen the transmission network so that we can really utilize South Africa as the proper gateway to Africa. With the African Continental Free Trade Area almost at fruition, it becomes more and more important that South Africa becomes a leading light, especially in manufacturing of componentry that can be utilized in the rest of the continent, because we already are the most advanced manufacturing country on the continent, and we want to really utilize that as a launch pad to attract new foreign direct investment for supply into Africa as well as South Africa. So with that, I will conclude. My colleagues who are sitting in the front here, we would be happy to engage with anybody today. And I think we leave on Tuesday to really understand your business. And although we are not the procurers of the skills, we definitely would be in a position to introduce yourselves to the appropriate ministries who are driving this initiative on behalf of the South African government. So with that short 5 minutes I was allocated, I yield back to the program director. Thank you very much.
Mr. Goliath, just stay here. Thank you, Mr. Goliath, for your presentation. I would request Mr. Gautam Mazumdar to please felicitate Mr. Goliath. Can we have a round of applause, please? Thank you.
Good morning. Now, this is the panel discussion which we are all waiting for. The synergy of the solar industry with the transformer manufacturing to transform the nation, a clean energy nation. To do the panel, I request the panelists to come and please occupy the dais. I now invite Mr. Manish Mehta of Sunshore. Please come and occupy the dais. Give a big round of applause and welcome him here. Mr. Rajiv Goyal of Renew Power. Mr. Sanjeev Pushkarna of Wari Energy. From the transformer side, none other than Mr. Anirudh Jala of T&R. And to handle this tough team, our own brethren, Mr. Hartek Singh. Please. If the sparks fly during the discussion, be ready to enjoy it and devour it. And you have a question and answer time too. Over to you, Hartek sir, to make this program a big success.
I think Prakash's energy now is going to be a little difficult to, match up. But anyway, thank you. To begin with, I am personally humbled today. Sitting on the dais, I thank IEEMA, I thank Trafotech, firstly to give a person like me an opportunity to come here and sit among such stalwarts and eminent personalities, specifically on the subject which has been always very close to my heart. People who know me, let me give you just a minute of a background about me that make things more interesting. I started my career as a salesman in 1988 selling transformers for a company called Alstom. That is where the journey started. I formed a company in 1991 as a trading house, again selling transformers, again for Alstom. So basically the whole journey of mine personally has been primarily focused on transformers, and that's where today as an EPC company, transformer has always been a very close to my heart. And imagine sitting right in front of you and the subject is transformer and renewable. It could have been anything better than that. So once again, thank you, the whole faculty of Trafotech. Thank you, IEEMA, for giving me this opportunity. And now I come to the star-studded, the team which has been given to me to interact. And I begin with Mr. Manish Mehta-ji, a co-founder of Sunshore. When you talk of entrepreneurs, it gives you a very different kind of a feel of the challenges, how they are taking forward, the challenges in the power and renewable. And a journey where he started from a grassroots, touching base, the rooftop, and picking up the best of the client base so that, you're talking of the very high standards of quality and, the overall solution, what you're trying to give to a customer. And today, he is sitting with us as an IPP, independent power producer, which I think is one of the biggest challenge this whole renewable space is occupying. And next to him, none less than Rajiv Goyalji, again a powerhouse. I will not touch that he is a supply chain head, vice president of supply chain, if I'm correct. But more importantly, a man with 36 years of experience, started his journey from L&T, and just look at the cycle of the, how you started with hydrocarbon, got into petrochemical, power, and now renewable. तो अभी कार्बन के वो जो वहाँ पे जो हुए थे अभी वो जीरो कार्बन में काम कर रहे हैं. But what a journey, 36 years, a powerhouse, renew power. So that's, we are going to be, part of the sharing the journey and the challenges what we face. And now we have Sanjeev Pushkarna ji. अब इनके बारे में तो एक इंट्रोडक्शन देना बड़ा मुश्किल है because he is representing Wari, which is a 5-dimension, I won't say 3 dimensions, a 5-dimension company with all kind of portfolio. But here he's going to play a role of the challenges of EPC. So we are going to touch base with you about the challenges, how the EPC businesses is, facing and what we are working around. Again, when I look back at him, close to my heart, he was a man with the Crompton Greaves, selling transformers. So he knows in and out a lot of, the deep down, pains of the transformer industry, what we go through. And then a reverse part of it, 16 years in Sterling Wilson. It couldn't have been better than kind of an EPC, what the see-through of the journey, what he's gone through. And now he's leading with the, again, supply chain for Wari. And in the extreme part, Jala Saab, a CTO of one of a leading transformer manufacturing company, T&R. And 20 years of experience in T&R. I respect people, who have that longevity of in one company, and I respect you for that. And welcome to be, amongst us. And now we take on having each one of, the panelists here. I will touch base the subject to begin with the IPP. See, we are into the journey of renewable. Fortunately, I compliment the government of India, who has given us, this country, a great opportunity of, taking the whole power sector by bringing in the renewables in this country, giving the targets, opening up this whole industry. And here is the country which is talking only of the growth. So I will start with Manishji, with you. See, as an IPP, what what is your, how do you see this business with the kind of target which our Honorable Prime Minister has given to us of 500 gigawatt 2030? I'm sure you must be having your own plans that how would you want to take this business as an IPP? And what are the challenges are you facing in this renewable space as on date? Over to you, sir.
Hello. First of all, good morning to all of you, and thank you, Trafotech and IEEMA, for making me the part of this panel. And I think this is a good opportunity to bridge the gap between transformer companies and IPP. And I think we together have to make sure that we attain this wonderful dream of our Prime Minister, which is a 500 gigawatt of renewable energy. So starting with Sunshore, so at Sunshore is a leading renewable energy power supply company. We cater to both business houses in CNI and then utilities also. We currently have around 600 megawatt operational capacity, and we want to do 10 gigawatt by 2030. And now, as we understand that we are moving from a plain vanilla solutions to hybrid and RTC kind of solutions. So at Sunshore, now moving forward, based on our grid requirement, we are also planning ourselves. We are also doing ourselves so that we can cater to high CUF hybrid RTC solutions to renewables, which is the demand of the hour. So this is about Sunshore. With regards to the challenges that we are facing as an IPP, so one of the challenges that we are facing is the connectivities and the delay in installation of substations so that the power can be evacuated. So that's one of the challenge that we have been facing, and that is a result of a lot of issues. One is in supply constraints, supply at the circuit breakers level, supply at transformers levels, and then there are ROW issues. So this is one big challenge that we should have an evacuation system which can evacuate power, which is the must thing to start with. Second thing is, yes, as a company, we have to acquire land. Land acquisition challenges are also there. And then, yes, as every, like us and Renew and other companies, we are doing our own bit to set up plants as soon as possible so that we can evacuate as much as power. So that's with regards to the evacuation thing. So coming back to transformer per se, so transformer, one of the biggest challenge that we face is the supply timeline. The supply timeline, if you talk to any of the transformer, the transformer manufacturer, the supply timeline is minimum 12 months. And for us, 12 months, because we want to set up this capacity very fast, right? That's the demand of the hour. So even this 12 months is not good for us. And if we see China, there the lead time is like 3 months, 4 months, 5 months. We have to catch up with this. And one of the issue that we believe is we don't have standardization of ratings. I think across the industry, standardization of rating is important. Because every time a transformer manufacturer has to work on that particular design. So first the RFQ is floated, and then it takes 3 months for closure of technicals, and then another 3 months for closure of drawing. So 6-7 months is being wasted, which can be utilized for manufacturing. And that actually reduces the capacity out for the transformer also, transformer company also. So we are working on underutilized capacity. So if we standardize the rating, then it can help us in reducing cost also and reducing timeline also. So that's the one thing that I think we as an industry should strive for, standardization. And even the CEA in 2021, they came out with a guideline that we should look as a whole ecosystem to standardize things, so that even we can develop the service industry per se. Because if you have a standardized rating, then people can have standardized spares at every different locations in India, and if transformer fails, then it can be replaced fast. So transformer is a critical component for us, and it's very, very important that the downtime is reduced. So standardized rating is very, very important aspect in that matter. So,
Yeah, I think well said. And before I move to Rajiv, Manish, let me give you a little bit of a comfort. And this is to proceed to all the renewable space, IPP who are working on. See, when we're talking about transformer, uh, there's one good news for, because I stand here, sitting here representing the transformer faculty, and so let me tell you, there is about approximately 4,000 crore of capex which is already there, which every transformer manufacturer is getting into an expansion mode, and they're doing investments and enhancing their capacity. So that should be a little bit of a comfort zone for specifically the IPP, space. Today, if I see the capacity of the transformer, industry across the country, it's roughly about 5.5 lakh MVA, if I'm correct. I think, and as I see the investment going on, this should rise to 7 lakh MVA, as we move on another 2 years. So this is a one little comfort, but yes, I take this is for all the transformer industries, that you need to come out with a standardization of your capacity. This is going to make your life easy. Because everybody, when we are talking of a 300 megawatt, this is a standard in renewable space which is going on. It's a 150 MVA, 160 MVA, 170 MVA, 180. हर किसी के पास एक अलग-अलग रेटिंग जिसने डिजाइन कर दिया वो आगे पड़ोस देता है. और इसका जो चैलेंज जो टाइप टेस्ट वो सब वो अलग है. So very well taken point. So if you all get together and standardize, it's going to make your life easy, and definitely it will benefit the IPP space as well. So now, Rajiv ji, you are, as a company, Renew, you are the leaders, you are the icons in this, space of renewable. You have had a wonderful journey through. So how do we see the renew power, in the future? How do you see your in 2030 to the future of Renew Power and the challenges as we shared with Manish? Over to you, sir.
Thank you. Good morning to all. Thanks once again to give me the opportunity to share our renewable thoughts. As far as Renew is concerned, we have 12 gigawatt of assets under operation, and 24 gigawatt are in plan, where we have a confirmed pipeline, not only in papers. So that's the kind of volume we have confirmed on. This is one company. The overall industry, like what Manish and Singh Saab is told, 500 gigawatt. Today we have around 190. Let's take 200. 300 we have to complete in next 4 to 5 years. If I divide into per year, it becomes 60,000 MVA of transformer capacity. This is apart from TBCB, Black Power, and now Government of India has gone for some thermal plants, BHEL and all that. If you add all those things, we should ask the question, can we spare that 60,000 MVA of that certain rating, not 765? Let's siphon it out of what installed capacity we do have. Some of the players, they work only on the 765. Because renewable, they don't operate on that. This is only majorly, now 80% is on 400. So can we spare that? One challenge on the capacity building. Secondly, if you see, divide into two parts. Upstream side, we have a solar plant. We build 1 gigawatt at one location in 6 months' time. That's the industry norm now, I think, Manish and all. At least we build 5 to 6 months' time. That's the allocated time to us. Because all other components has become commoditized. If you go to downstream side, the only challenge is the substation. Substation, the biggest elephant is a transformer. So one is the solution I think we touched base upon, Manish rightly touched, why don't we make it an engineering goods to a commoditized transformer? These are my catalog. These are hard-take make transformer H1. These are 250. This is the volume. This is the specification. This is my catalog, like Amazon. But looks little difficult, but it's a collaborative effort. If we IPP joint hand, it's a lot of initiative has to be taken from IPP side, not only from transform side, because every buyer, when he sits, he has the only power of, I can say anything what I like, but the competency lies on the other side. The whole engineering competency, technology competency, what you can give us as a best solution. It's a black box for IPP, right? We want this input of voltage should go to this side, we should get. You are the people who can give us the best solutioning in terms of time, delivery, cost, maybe reliability, sustainability, and also and so forth. Right? Why don't collaborate? make it commoditized. This is the catalog, this is the starting, no engineering evaluation, 3 months, drawing approval 3 months, and then technical clearance, then clearance to production. 7, 8 months. This should be the right delivery time. I mean, after that we start counting zero date. That's become 12 to 15 months. I think Manish was sober to say on your side, I think 12 months. I mean, 12 months you write on the PO, no, it's right from the date of everything clearance. My worry is that clearance from day 0 to clearance is 7 months. And this is my completion time of solar plant. So basically the whole, we are here, all of us, I mean the best of the minds here on the other side, how to make that 7 months to 0. And that's very really doable in today's parlance. Because standard capacities, plant capacities are there, 400 voltage rating is almost fixed. Right, 220 we don't have much. But 3, 4 sizes, 315, 250, 265, whatever the CA guidelines, 15% more and all that. Similarly, if you make catalog, we can bring down the cost also because it's a mass scale production. Your cash flow will reduce, 7 months duration will reduce, your turnaround of a transformer from 18 months to 12 months, 10 months, then 6 months, it will help you cost effective. Your CFO will be much more happy to give you 10% discount. So as a collaborative effort, add together as a team in this auditorium. I mean, this the whole. I think we can take one thing from here. I mean, this is one thing from my side. I mean, we can synchronize the product, the plant completion time 6 months with the substation time. Why can't we make substation as a catalog, as a modularized solution for this industry at least? Because we have that preconceived thermal plant used to take 4 or 5 years. Substation is a lot of float, 2-3 years kar lenge aaram se. But renewable industry has ask is very, very high. Similarly for wind, now BESS is coming, BESS is a plug and play, you bring it, install it, 2-3 months time, then evacuation is common. Number one. If you see on the manufacturing side, it's totally still, if you see, it's a totally grossly manpower oriented industry. How we can automate it, how can we use of robots in this? It will help quality, it will reduce the cost also. See the neighboring countries, I mean 2 to 3 months commodity product. Any rating you ask for, they will deliver it. Whole country they have a 1 voltage rating, 1 spec of transformer. Here one state to other state transformer specification doesn't match. If you have spare for Maharashtra, you can't use in Kerala. You can't use one IPP A, you can't IPP B. What's this? Unnecessary inventories are being piled up and somebody is asking for the inventory. Somebody's spare transformers are like this. No, it doesn't match my specifications. If you ask me what does it match, I don't know. My engineering people has given me. So only the you people has to come together, I mean all of us, and then make it, there's nothing major difference. It's a block. It's a solution, it's a black box. This is a voltage, I'll take the guarantee, I'll take the whole solution. I mean, that's I think from my side, from this industry.
Well, thank you, Goel Saab. I think the message is very loud and clear. For us as a transformer industry, we need to come forward and offer a standardized capacity of the rating. और शायद मुझे लग रहा है आज के 2 साल के बाद a time is going to be there when 150 MVA will be ready off the shelf with one of the manufacturer. That if anything, God forbid, there's a breakdown, here is it. We are not going to have work on any downtime. Let's make our future sustainable and reliable. And if it is only possible, अगर हम ये करें, standardize करके रखें हर capacity को और IPP को the best of the timeline, best of the price, everything will benefit out of it. और ये मुझे वैसे चलो गोयल साहब ने ये बात बोली नहीं, बट आपको मैं एक चीज़ और भी बोल देता हूँ. रेन्यू एक ऐसी कंपनी है जो खुद भी EPC करती है और इन्होंने दिखा दिया. जब हम जैसे लोग जब जाते हैं, मतलब मैं तो नहीं, मैं तो अब यहाँ पे एज ए मॉडरेटर बैठा हूँ, जब हमारे भाई साहब जाते हैं EPC के और जब कीजिए हमको तो 8 महीने लगेंगे, तो ये कहते हैं भैया ये वाला प्रोजेक्ट देखो मैं 4 महीने में 6 महीने में खत्म करके बाहर निकला हूँ. तो ये they are multifaceted. So please, it's a wake-up call for the transformer industry to consolidate yourself. So हमने IPP का एक challenges देखा एंड नेचुरली जो बेसिक चैलेंज अगर हम आईपीपी के हिसाब से देखें, अपार्ट फ्रॉम जो टैरिफ के जो उनके चैलेंजेस चल रहे हैं, एवरी टाइम देयर इज अ सेकी बिड एंड वो कुछ पैसा वो डाउन होता है या ऊपर फ्लक्चुएट होता है, बट द बिगर चैलेंज इज ऑफ कोर्स द कनेक्टिविटी जो ये फेस कर रहे हैं आज की डेट में, और उसके ऊपर जो टाइमलाइन है, और वो टाइमलाइन इन सबके ऊपर सबका इनका सबसे जो ऊपर जो चैलेंज है वो ROW है। प्लांट लग जाता सबको होता है, जब कनेक्टिविटी के साथ और वो जब वो लाइन को जब कनेक्ट करना वो एक ROW एक और खड़ा है। सो दिस इज वेयर इमेजिन द पेन ऑन विच एन IPP इज टुडे ट्राइंग टू look after each one of us, because as an IEEMA and as a manufacturer, we look upon them for filling up our production line. So it's time that we need to stand for them. So ये डिस्कशन जो IPP की करने के बाद अब हम आते हैं थोड़ा EPC की गेम को समझने में, और संजीव जी से बेटर बंदा नहीं हो सकता। सो संजीव जी, आई वुड लाइक टू know from you as an EPC the challenges which are being faced by IPP, which actually carries forward to you only, because ultimately you are the solution provider for them. So how do you handle their challenges and your internal challenges? So over to you, Sanjeev ji.
Yeah, good morning. Thank you for inviting me on this panel. I represent Wari. They are into multifaceted, as Hardik ji said. But today I'll short it down to only EPC. And as on date, we are EPC of almost 3 gigawatts. And next year, our target is to make it 6 gigawatts of EPC, which we are going to do in India and maybe outside India also. There are bidding in Middle East is going on. So we'll be expanding outside India also. So this has been, and I have been in past in Sterling Wilson, where I have spent almost 16 years, and I have been doing only EPC there. And we have worked both in India and outside India. The major challenges which we have faced, one of the good news is that IPPs have taken one of the burden out of us from EPC, that they are taking care of transformers, because that animal cannot be managed by us. It is a delivery is clearly a challenge. And just to give you a perspective, I have been interacting with other countries also, and when we are doing EPC outside. US also is facing a major issue, where the deliveries they are talking of 3 years and 2.5 years for power transformers. So this is a blessing in disguise for Indian manufacturers, like many of us of the transformer manufacturers in India industry. We can develop the capacities here, and we can serve the US market, because they are just starving to get their transformers. They don't have manufacturing capacities there. The only challenges is the reliability and the quality. And that has been a major challenge whenever we interact with those customers, that they always feel, and they want to come out of China, because a lot of people they were trying to get from China, but thanks to Trump now, they can't buy from China. So there is an opportunity for all of the manufacturers in India to cater to those demands. I was going through a session from Africa, South Africa. There again, the transformers are required, but again, not many Indian manufacturers are approved. So they also have to go to either Europe or other countries. So we have been facing with a challenge on deliveries. So as I said, IPPs have taken care of power transformers, but many times what happens is inverter duty transformers, it is still a baby of EPC. And we need to take care of that. Or the orders are finalized by them and it is routed through us. So again, it becomes our baby. So the transformer manufacturers will give some delivery timelines, and we need to ensure that. And the quality and reliability is an area where I have found we have been lacking. I mean, it's really sad that not many companies are following the protocols. And we have faced challenges. Not only, I'll give you an example, like what we have done is now, any transformers what we buy, they should have a short circuit test, a type test. It's a special test, but that is a mandatory requirement nowadays. But you ask any manufacturer, they are not confident. They will say, we'll do transformer first short circuit. If there is a 40 transformers order, They'll wait for short circuit test to be completed, then only they can. So till now, the confidence is not there that they can start manufacturing and they can supply transformers. So when we have such a mass knowledge within India, and short circuit is basically a design, it's not on raw material, it is on how you manufacture the transformers. Most of the failures happens how you manufacture the transformer, and that should be taken care by the manufacturers. And they should give a confidence that one of the areas where we are finding, because every time you see ratings are getting changed from 8.8 MVA inverter duty transformers, 12.5, then 13.5. Now today we are 17.6 MVA 5-winding transformers. I heard somebody did 20 MVA inverter duty transformers. This is only in India which is happening. Outside India, people are not going beyond 5 MVA or 6 MVA. That is the maximum rating. But India, we are going with 17.6. And one transformer fails, the entire block is out of network. So that is the biggest challenge. And again, I'm telling you that reliability, when we are working on lowest cost, we need to ensure that basic reliability in manufacturing is taken care of. Because if we are going to, there is a failure of a transformer, the entire grid goes down. If there are 5 failures, and if your power transformer fails, you have it. So my request from EPC side is that once we are forced because of the constraints of pricing, that we need to negotiate. But then as a manufacturers, you need to take care of some reliability factors. There are some non-negotiable items which you need to take care of it. If you have to design a transformer, please ensure that if you are even supplying to renewable sector, you just can't assume, it's a myth that transformers for renewable sector will work only for 4 hours, 5 hours or 3 hours. Today with BESS coming, we are going to see loading of the transformers, and you need to ensure that transformer is designed on a full loading capacity. 110% if loading is there, you need to design that transformer based on that. You just can't assume that renewable sector, it will peak only for 2 hours, 3 hours, because we have seen transformers getting manufactured, tested in laboratories at 24 degree, 25 degree, whatever temperature, at lab temperatures. But when it works after 1 year, the transformers are generating gases. And it is not that only, I can't name 1 or 2 vendors, it is applicable to everybody. Today, I have bought transformers from ABB Turkey for an international project, because India may not be here. Even those transformers have failed after 1.5 years. So I think as a manufacturer, it is not that we are saying only Indian manufacturers are like that. There is a myth, and when you go deep into that, the failures are because they don't design transformers considering that the loading will be there for continuously 24 hours or 20 hours. So these aspects need to be taken care of it. One of the issues which we have discussed is that we are buying transformers, 40 transformers for an EPC company. Heat run test will be done only on 1 transformers. Okay, they will load radiators, they will, everything will be done for 1 transformer. The balance radiators will go directly to the site. And once the transformer radiators goes to site, and when they are installed, a basic thing like flushing of radiators with oil, if it is not done, it can ensure that the entire transformers, short blasting particles can create havoc. And we have faced that issue in one of the international projects. So this is the basics of manufacturing and reliability issues, that flushing of radiators with oil should have been done. You can do RCAs, you can do all that. But this can't be taught to a manufacturer. This is a basics which you have to do. But then people are taking chances. People are trying to give transformers to renewable sectors, and they are still working that it is a government transformers or some it's kya chalta attitude. So something that we need to come out of it, because We just can't keep on supplying transformers with some assumptions that chal jayega. Because today it's a competitive market, and I request all of the manufacturers to just look into all those aspects while giving transformers, because somebody is designing, sitting in the design office, but the manufacturing is happening at the shop floor, and the dispatches are happening. Some decisions taken by the team can create havoc at site, and that needs to be controlled at the time when the transformer is getting dispatched. So I sincerely request all of you, and as a manufacturers who are supplying transformers, that there is an opportunity there. We can supply transformers outside India. There have been cases where people have supplied transformers outside India and they have been banned, and because of quality. And fortunately now, with China Plus policies coming in most of the countries where Europe is getting opened, US is getting opened, I sincerely request, when we as an EPC companies are going to do EPC outside India, we are all dependent on the manufacturers from India to supply us transformers which are reliable and which can help us take care of the uptime requirement, which is the basics for the solar plant. Thank you.
Well, Sanjeev ji, so beautifully, I think you touched a very sensitive, we've been talking of the timeline, we've been talking of standardization. You went a little deep into the design, but you've been very modest. As an EPC, he's not spoken about the major challenge as an EPC, where they are facing the biggest challenge of while they're doing an execution of a large scale of a land where the skill resources is a very big challenge today to meet the HSE norms of their safety and other factors which they are, it's a mandatory which they and which is scaling up every year by year in this country, which they are accountable. Apart from the supply chain which we've been talking, and here is touched a very sensitive issue, the transformer inner story of it, what is within the tank, what we are concerned. See, we should not forget one thing. हम ट्रांसफॉर्मर बना रहे हैं और अब जो बात हम जो कर रहे हैं इस प्लेटफॉर्म में, you are talking of generation. It is a generator to whom you are supplying. And can you imagine on what risk an EPC stands on? If there's one failure or a tripping, the generation loss, he is accountable for that, because he is given a commitment of a complete generation of the megawatt what he is building. So look at the risk on which he is standing on. So I think it's time we as a transformer manufacturing company has to understand that we are here with a very big responsibility when we are talking of renewable. So I now very nicely, thank you for, now I'm having a friend who's sitting, Mr. Anirudh Jhala, representing the transformer faculty. Jhala sir, before I pass it on to you, the pain, transformer पहुंचता है, ये जो radiator का जो issue है, ये तो चलो one है, एक ये है, and there is another part of a thing that you slowly get a beautiful seepage of a leakage coming out and trying to give it a different color to a transformer. I think it's not very pleasing, to a technocrat, especially into a site. And as you look after the seepage part to take control, and then you have another beautiful part which is not good to us, is the heating, right? In other sphere is fine, but here, this is another curse, which is a issue sitting at a site which is 300 kilometers away to the national habitat, and you are facing this problem. How do you see this challenge as a transformer manufacturing, and over to you, looking at your insight?
Thank you, sir. Yes, of course. I mean, supplying transformer, it is a matter of, great responsibility, because this is something, which is likely to, work, give full of, its service for more than 30-35 years. Unlike what we see in India, wherein, typical warranty period or typical service life assumed, of transformer, is 5, 10, 15 years. If you go to developed market, USA, 70% of their population, the transformers are more than 35 years old. 10% of their population transformers are, more than 50 years old, all running at full load without any, technical issues. So this is where, so what is the gap? As rightly said by Singh Saab, aesthetic is one thing, which uh, it is a matter of responsibility, as a transformer manufacturer, we have to work on. Thanks to, sir, the new technologies, wherein conventionally from SRBC, kind of gaskets, now technology has shifted to, the NBR kind of gaskets, HNBR type of gaskets, with the O-rings, with the stoppers. Standards also have recently, made changes before 3 years, wherein, the method of the leak tests have been drastically, improved from conventionally followed in terms of duration, in terms of test methods, and so on. So I perfectly and I completely agree with you that, whatever is the performance of the transformer, what is the first scene is, what is the seepage coming out of a transformer or leak coming out of transformer. So this is where, we as an industry, should be targeting on, what is happening at automobiles, irrespective of high pressure and temperature, if that doesn't leak, why my transformer, should be leaking. And on behalf of our industry, I would like to give confidence, to all the users that we as industry, we are working on, supplying transformers, leak proof. Very recent change which is also started amongst transformer manufacturers, because what was happening that irrespective of the leak testing which was done at factory, it was not done at site. So this is something which is now added by all the manufacturers, wherein because a lot of activities are done at site and many times it is done by OEM or subcontracting and then further subcontracted. So idea was to do the leak test at site after full of its assembly. Heating is also another critical area wherein because everything is dependent on the heating. Life of transformer is life of insulation, and life of insulation is greatly depending on the temperature. So this is also one thing wherein the standards are now working on, because conventionally, historically, if we see, there is no dedicated, Indian standard, which talks about transformers for the renewable application. Worldwide, there is only one standard, which is IEEE standard, which was available, which was talking on, transformers with application of, DPVs, distributed photovoltaic, solar cells, having a different, loading patterns. So this is one area, sir, wherein BIS ETD 16 is working. Very soon they'll be coming out of a standard which will be talking only on the transformers, for having application for the solar transformer. The reason being is that whatever is designed, whatever is manufactured, the ideology or the methodology, are very different from a conventionally designed, distribution transformer, especially when we talk about IDTs. While the distribution transformers, will be working on a typical fixed kind of a load pattern. In case of, IDTs, we have a cyclic load. So not only the clamping pressures, but the materials which are used, the bushings which are used, the sealing systems which are used, are always exposed to, different temperature throughout the day, and this phenomenon will be repeating, throughout the life of the transformer. So established manufacturers have already started, having short duration heat run test for all the transformers with the thermographies. But the standard is also now coming up, with the new testing methods, which will be taking care of, heating aspects before the transformers are, supplied, to the site. So, sir, on behalf of industry, I would like to give confidence, that when we will be meeting in any panel discussion next time, I'll be in a better position, to share that, sir, last time I promised and now the standard is published. Last time we discussed on the leakages, now, you see, you take references or, feedback from your side teams, and definitely, we'll be having a positive note of that, sir. Thank you.
Rajesh was wanting to speak something. Yeah,
I think
please.
I'll add what Sanjeev and told. For a 300 megawatt plant, which is one unit for us, I mean, in the renewable industry, that's become a least count now. For a 1 month, the transformer is down, we have revenue loss of 20 crore net. 1 month only. And transformer is something which goes wrong. Minimum replace time is 3 months, minimum. Just imagine the kind of pain it will cause to. Let's forget about contractual and all that, but it's a national loss. Power is being generated, not being evacuated because of some link is failed. I'm trying to say it's a kind of importance that it's a so critical parameter, and there is no standby. Like in my previous, when I was in cane and oil and gas, we had a oil gas separator compressor. One vendor was there saying, if you take, we used to take standby, right? Well, my machine, you don't need standby. I take that warranty and guarantee. And that's the only premium, 5% I'll charge. Can we hear this from this industry? I mean, and I did that experiment. It's still working. So basically, we should get inspiration from that industry, oil and gas. I mean, normally Cell, if you take oil and gas, and then over and above, I put Cell as a customer. I mean, they have that kind of standards. That's why Cell is known for. Can we come up, I mean, gradually? We are there to support, I mean, because it's a mutual loss. It's an industry loss, it's a national loss. And it gives bad name to the industry. What he said, Sanjeev rightly said, it gives a bad name to the export market unnecessarily. Where we have a lot of potential in terms of installed capacity, in terms of like China is not there, we are there, we have a lot of potential is there. So why don't we encash on that potential in a big way? The only thing is when we go outside Indian, the first thing it comes to my mind whether they'll ensure to the quality specified. Can we say yes, we can? That's one thing we should hear up when we travel around. Thank you.
I think, well, again, a much, much bigger responsibility on which we all stand when we are talking of the transformer faculty in the industry as a manufacturer. And I think we owe this back to the renewable space for all what they are filling up our production line, for all the growth and the down, I would say, the top line and the down line which they are ensuring for us. I think this is the least what we have to give it back to them. So thank you very much, Rajesh, for that insight. Because this is something very sensitive, which I always was close to my heart. That when you're giving it to renewable, you come out with a much, much bigger responsibility. Though transformer should never fail in any area where you work on. Now, I would like to go back to my, again the IPP, because we need your support. For the transformer industry as well, with a promise that we will come out with a very good, robust kind of a manufacturing, product, which will give you not only the reliability, but also a sustainability on the space where you work on. But we as an Indian manufacturer look upon the IPP for taking us to the export market. And through you, we look forward. So, Minishi, if you can give a little insight to this, that how can you support the transformer industry? Of course, with the condition of a promise that we'll give you a world-class product. We need a support of the IPP. And how do you feel IPP can really play a role in export of the transformer industry?
So, Sunshore is supported by Partners Group. And Partners Group is a private equity firm which has multiple renewable energy platforms in US, Europe. So we had a conference 1 month back, an entrepreneurship conference, where all companies came who were under Partners Group. One common issue across everyone. So there are companies who are best companies, there are companies who are wind companies, then solar companies in US and Europe. One common problem across everyone is availability of transformers, availability of power transformers. And the lead time going like 2 years, 3 years, and that is one factor because of which they are not able to put the capacity. And they were asking us to help whether they can procure from India. With regards to, so everyone has that problem is common across all companies. And I can correlate with them because we were facing the same problem. So I think we as an IPP, like now we meet people at multiple forums where we can push for this. But again, then the quality which everyone has pointed out, we have to be top notch in that. And I see with regards to my discussion with multiple transformer manufacturing, the potential is huge. And I believe that we can create global companies of transformers from here. And we are very competitive also. So I think this is a good opportunity when world is going away from China and trying to depend on India. And we are being competitive also. We can create global companies. And you see the kind of demand that is coming. So this 500 megawatt is just like renewable in terms of solar and wind. But you see the BESS is also coming. So for BESS you need like low voltage transformers also and high voltage transformers also. So that itself, as per Ministry of Power, we have a requirement of 200 gigawatt hour by 2030. So the demand is huge. And I think we are very good at it. We are in electrical components, we are very good at it. And we should use it to create global companies in India. Yeah.
I would echo the same to Renew because I'm sure you are also working on export, market. Can you give a little insight about your, journey of your export, how you look upon this, and how can you support the transformer industry for that?
See, looking for the export market, in addition to what a large potential we have in-house, there are 2-3 things what they seek for. One is they are a lot of pressure on the sustainability, ESG governance, like greenhouse factories. So if you start thinking of those lines also in parallel, rather than कि यार ये पहले ये कर लें बाद में ये सोचेंगे, because a lot of, let me tell you, export market plus we have a insight in-house also some of the export conditions because they are imposed by our investors. Like we have ADB and CPBIB, they also look for ESG compliance, greenhouse, what biodegradable oil we are using for these things, what circular economy, what percentage of circular economy we are using that. So I think one in the industry for export compliance and plus maybe who knows in the future we people in India may be asking for those because to comply our financial requirements. So that's one of the things we should comply, and one we may try to give weightage more to a greener manufacturing units or greener component, less carbon footprint used in the manufacturing of the whole cycle chain, value chain in all the components together put. I mean the days are not far off, we will be asking apart from your dollar value to carbon footprint being used in this whole manufacture. Like this started already in steel. So we are trying to use, I think, so green steel, there's a lot of weightage is being given now to this country, and a lot of steel manufacturers are investing in this. They are changing the process of manufacturing the steel. They are using the green power for powering their steel plants. Similarly, this is the industry not far off. I mean, this is one of the attachment which you will make a one line above the others, including in India as well as for the export market. One, of course, quality has been touched upon a large way. And secondly is a technology. I mean, technology in like IoT based. I mean, all of the countries, they are working on this. Like, what is the biggest problem if there's a quality issue happens is a maintenance. We do post-facto analysis, and then after the event has happened, we start doing. IoT based and AI based people are already working on the transformers, so which is giving me event-based condition-based maintenance. So that is very important. Actually, that gives edge over others. And these are not high investment area, but returns are very high. Like for example, a call can be made by a 1500 rupees phone also, but Apple charges 1 lakh rupees, only phone call. I mean, this is the technology upgradation and getting the value. Their margins are, I mean, their PAT and EBITDA for the only Apple is, I mean, one of the countries' GDP. because of technology. I mean, this is the industry where lot of scope is on the technology enabled transformer. It's a passive voltage converter. Let me tell you, I'll normally call it a transformer. It's a passive voltage converter. Why don't we make it a smart power management hub? If we think that journey from A to B, how I have to travel, what all kind of power electronics I have to use, IoT, AI, and all that so on forth. What I have to use, we used to start traveling thinking of those lines. Otherwise, if you see only a voltage converter, your margin will also be like this only. Unless otherwise we add a layer of technology, make users friendly life easily, and you don't get such a premium, high premium. I think that's the 2-3 inputs for making industry more of export friendly. I think I have.
Yeah, thank you so much. So I think now we are going a little more and more deeper into, as we move on to the discussion. We were talking of standardization on the capacity, so that we're able to match up the timeline and the design pattern. They're all minimized, and you're able to give a good standard offering to the. Then we started talking about the quality. And now we are talking about smart transformers. Is that what Rajeshji touched? So, gentlemen, especially the transformer manufacturing industry, it's time to wake up and catch up with the time. Because it's not only we need to cater to the Indian market, we need to talk global, and nothing less than, better than an IPP platform who can really give you that kind of a security. So thank you, Rajesh. That was very insight. Yes, we need smart transformers. We need digitization where we are talking of online monitoring. And now I will touch base, moving a little bit more into a technical part with my friend Sanjeev. He spent good number of years in Crompton, so he's seen both sides of the story as a transformer man, and now he's sitting on a EPC. When we are talking of a transformer, we are talking of a high quality transformer. We will also touch base somewhere deep down transparency, that what comes in the transformer, how true are you to your customer, from where are you sourcing your CRGO, what is the grade of the CRGO you're putting into a transformer, to make sure that what is the final output, your customer is secured, that a right kind of a material has gone in. So from the technical part of view, Sanjeev, what is your take that the transformer industry should, take care of the aspect on the technical part?
Yeah. As rightly said, I'll give you an analogy of how we are supplying modules to US, where there's a traceability is a major issue. And if whatever raw material I'm using, I need to ensure that the traceability to the last point is proven and given to the customer. Why they are doing it? Because they want to ensure quality all around. They want to see the raw material from where it is bought, whether it was as per the specifications, requirement, what is being made as per ESG guidelines, as Rajesh told. All those compliance were done or not. So similarly, what I think and what I suggest on transformers manufacturers, that they should, CRGO is one area where a lot of us are just getting it cut at some job work being done. But traceability of whether they have used virgin on raw, right material, A grade CRGO, is always a question mark. You just can't go back and check whether after 1 year, if there is an issue, on paper, whether they can really prove that this was from Nippon or what was the grade. They will always give you some answers, and you'll be around and around and around. So this is one area where, as a manufacturing companies and from Indian manufacturers, where we have to ensure whether it is for India or outside India, traceability of all raw material, what we are using, the old TCs, the permawood, the insulations, CRGO, oil, that needs to be tracked down from where it was bought and what was the requirement, whether it was as per specification or not, and whether we have followed the vendors whom we have committed. Because most of the time when I am buying transformers and they agreed for GTPs and the manufacturer name, during the manufacturing they will come up, sir, ye change karna hai, ye change karna hai. I don't know, this is the standard which I have seen, and I am not naming one or two companies, across all the manufacturers. During manufacturing they will come up with some excuse because of supply chain, they want to change the make. I don't know why we are not able to control that aspect. When I'm buying 40 transformers or 50 transformers and I'm giving you almost today 6 months to supply because I'm not able to get in 3 months those transformers. So that needs to be taken care of. And one more area which I would like to head for renewables, as Anirudh said, there is no specifications or requirement met that what should be the transformers, what are the minimum makes, or what should be an example of that. At one of the issues where we have faced is in an inverter duty transformer, HV winding should be a disc winding. People are using layer winding, or they are able to use. So I'm not saying disc winding should be the right way, but over the years what we have found that if we are using layer winding, there has been gas formations. We have seen transformers getting failed after 1 year because of the heat cooling is not proper. So there are lessons or areas where we have suffered. So some companies are falling, but as a cohort, the entire industry, we are not following that. So I still come up with some companies coming up to me and said, oh no, I can give you short circuit design. I have done layer winding or HV winding. So it may have passed, but the question is whether it will survive the entire 25 years, 30 years. That is always a question mark. Whereas a disc winding, HV winding is a disc, the cooling is better. Why can't we just adopt it? There may be a cost aspect, but the question is whether a reliable transformers can be offered to an IPP and to the nation. That needs to be taken care of. Since there is ample examples, there has been a failures on that. People are coming up with corrugated tanks for more than 6 MVA transformers also. When we know that more than 6 MVA transformers, it's so thin, manufacturing of the corrugated tanks is limited and they are prone to failures. But still, everybody is coming up with new design. No, we can give you 7 MVA, 8 MVA corrugated transformer tanks or a transformer. So again, we need to come up with some specifications, learning the lessons what we have learned over the past so many years. Now we have an industry which has almost 10 years, more than 15 years in solar, which we have learned hard lessons. And all those, what not to do, we know. But only thing is now we need to document it, put it in some paper, a CA can come up, or some agencies should come up with some basics that these are non-negotiable items for design and raw material, so that the transformers, if they are manufactured based on those, will survive the test of times and they will last for almost 25 or 30 years. That is my humble request to the manufacturers and to the government agencies that they should really come up with some guidelines.
Yeah, thank you, Sanjeev ji. As you were speaking on, I was just thinking about, going back into the state utilities and the center. When a transformer manufacturer is supplying a transformer to a state utility, I remember, they have about, these 3-stage, 5-stage, 7-stage inspections. Now, the basic purpose of this was just to check, at each stage, there was a core, there was one stage of inspection, and this basically did not follow in the industry because industry was totally working on a trust base. And this is where I think we need to come back to build up that confidence back to the renewable space, specifically as we speak here, that Anuruji, what is your take on this? You need to, come out with some kind of a transparency, some kind of openness of showing it physically. And we have online inspections. You don't have to physically do it in times which was there. come out with a, kind of some kind of a solution where you are offering an online inspection at every stage of a transformer which is being supplied to a user. So what's your take on that?
Yes, of course. Transparency is the only, key, when we talk about supplying the reliable transformers. In fact, I would like to share here, example of what is done in US, US utilities and US OEMs, wherein, a 24/7 access of, the floor where the product is being made is given, wherein, you can log in and, access how your product is being made and, see that anytime. So yes, of course, this is what is needed in India too. Secondly, what is missing, I personally see, in India market, is a comprehensive design reviews. Typically, how we have been, dealing is, that after getting an order, the drawings are submitted, comments are given, but very few occasions, both, buyer and supplier are sitting across the table, talking, building reliability in a product, at the design stage. Because this is one platform, wherein the experience sharing, like what, Pushkarna Saab said, can be added, during, the product building at the engineering stage itself. So this is one thing which is started, at many, buyers. But then, comprehensively, if we see India as a country, then this is one thing which, we should be working on, together in order to, building reliability during design and so also, during the manufacturing, sir. Yeah.
Thank you. And I think when you're talking of new technologies, upgradations, smart transformers, I think you should have these online monitoring systems as a mandatory to your client base, because we should be talking more on preventive than on maintenance, So this is a thought process which has to start from your end, from the transformer industry end, not depending on the EPC or the customer and, from their point of view. You should be giving that trust and that confidence to him. जो राजेश जी ने बोला कि उसने बोला यार मैं तो तुमको वारंटी सब मैं ही दूंगा. I stand by that quality. That kind of feel has to be there. That is only possible if you are first correcting your in-house and then showing to the customer with a pure transparency of these kind of digital solutions which are available today, which wasn't there about a decade ago. So let's, upgrade our levels, upgrade our confidence, because we are working in which is a high risk where reliability and sustainability is key to the future of this country. And I think we are accountable, responsible to the IPP and to the EPC space as we speak on. So, as we are closing on with the time, I would also request, going back to my, to Manishji and Rajeshji, if you can give a little insight about what are your expectations from the government point of view, because you are, coming forward with a lot of investments, a lot of way forward. What is your take on from the government, policies, or what are the changes you would like? So if you can give a little insight on this, then if you can give it, then I'll put it out. Okay, I'll start with Rajeshji, please. Yeah.
I think that as the government is promoting some of the industries like solar industry on the upstream side, wind and all that, they are giving manufacturing some PLIs and all that. I strongly feel the government should think of this as an industry. This as an industry, like for example, a lot of R&D is required, what we have been discussing so far. Technology is required to make it IoT enabled and preventive maintenance and predictive analytics and all that. These things are, the government should fund, these things as a viability fund capping or whatever the mode of. So they should promote this industry as a technology driven and ESG oriented. More and more you go green, this government should give some sort of a tax rebate or tax brackets. I think that's, I strongly feel that will motivate this industry to go further in a very speedy manner.
I think the one point which is a very important point is regards to the regulations. So earlier for a 300 megawatt, they were fine with a 150 into 2 transformers, then 160 were reactive power. Now they have put a condition of 15% extra. So in terms of that regulation, there has to be clarity what is expectations from a transformer company and from an IPP, what kind of rating has to be maintained. Because if that is very clear, then how are we going to proceed in next 5-10 years? So that IPP and the industry can prepare together how we are transitioning to Because as the system become more and more complex, there will be expectations from transformers company and from IPPs. Because just to give you an example, if we are moving to a more complex solar wind hybrid kind of a system where you have a solar, wind, and a BESS also, the use of transformer will become very high. So there will be rapid cyclings, there will be deep to and fro flow of power, and the loading factor will also increase. So how are we going to proceed in next 5-10 years? That should be clear. It should not be, because we were discussing one order with one of the transformer company, and then we got to know that we have floated RFQ 160, and then now it is required 190, not 160. Then again we have to start the process again. So that has to be very clear from the government, what is the expectation from the manufacturing as well as an IPP, what kind of regulations they have to follow. And because this otherwise delays a lot of things. And yet, as the sir has pointed out, yes, some kind of PLI kind of a scheme where, and some kind of exposure to Europe and US market where there can be common conferences, how to promote Indian transformer companies outside. We have a potential, as I already pointed, we have a potential, there is a demand. Why not plug that demand? Why not create a world-class company of transformers here? Thank you.
Yeah, that is, thank you so much. Now, I would go back to my, eminent, friends sitting on here to begin with Sanjeev ji, with just a closing remark. How, with your, again, I go back to your experience, of 20 years, specifically in the EPC domain. What is your take to the renewable space and specific to the transform industry, summing up statement as we are, closing on to the time, and I begin with you, and then the rest will follow, please.
I'll again talk about, hello. So reliability is an area which again and again I'm stressing on, that we should have transformers which are reliable, because a manufacturer can provide transformers, can design, they have the design knowledge, but requirement, and they only can come up. We are buying transformers, unfortunately, I'm using a word unfortunately because price becomes a criteria. But as a manufacturers, you should be coming up to me and telling me, Sanjeev, current density more than 3.5 or 3 should not be allowed. If somebody is trying to give you more than that, this is prone to failure. You should be coming up with telling me that bushings are required of this size. Or you should be telling me that this type of voltages should be used, or this type of voltage should not be used. You should be telling me as a because if I have to compare the transformers, if I am buying, unfortunately, the cost becomes a criteria. But if I have to bring everybody on the same page, then at least I'll get offers on basics requirements where people try to play around and they try to cut corners. So you need to educate us, and then only we can, because you have the masters, you know where it can fail. You know which are areas which, if I have to take these transformers for my, whether I am buying for as an EPC, or since I am wearing a hat from Wari, I am buying for my own capex requirement. I am going to own that unit. So these are some basics which should be informed to us, educated on us based on various platforms where you have supplied transformers, and then that can become a basics for my selecting the transformers manufacturers. Of course, we can shortlist manufacturers like many companies does, that they will have to have so much criteria they should have supplied. But there is no transformer manufacturers whose transformers have not failed. So I just cannot tell who I'll take transformers only from a person who has not transformers which has not failed in last 1 year or 2 years. Because there are cases where transformer fail not because of manufacturing, because of some site conditions also. But then how to prove that? That will always be a question mark. The manufacturers will say it is because of site will say it was a manufacturing, and that ball games goes on and on. The best part is that we learn, we get educated ourselves, we have experience, and you people need to come up with some specifications, with some do's and don'ts, some list of raw material from where traceability can be defined, and then only the transformers can be bought. That will help the industry, that will help our mission where we can supply transformers outside India, and without any iota of doubt that this transformer will survive the next 5 years. We are not even talking about 30 years, even 5, 6 years, because of late we have seen after 1 year there is a gas formation, there are leakages, and this can be stopped. And as he rightly said, Anirudh said, US, this is not found. Other countries, the transformers are running for so many years, and we need to come out with some basics, checks and balances, so that these transformers keep on running, for which they have been taken. The last issue which I have said is, since we can't take care of issues which can happen, the SLAs. Today we know there is an area which transformers will fail. How best we can address, how best we can address that issue, that also needs to be taken care of. Most of us, when these transformer manufacturers comes to me, they will talk about deliveries, they talk about how will they supply. But in case there is a failure, I don't think anybody can confirm that within 24 hours that can be addressed and somebody will be at site, because these sites are very remote sites, and most of them will take more than 2 days or 3 days just to attend that thing. So this is also one area which so much transformers and gigawatt of manufacturing, renewable being come up in India, 500 gigawatt, there will be so many transformers. And how do we address those SLAs? That needs to be really taken care of by all of us, so that industry will not suffer.
Yeah, thank you, Sanjeev Pushkarnaji. Now over to you, Rajesh, with your closing remarks to the audience and to the industry in general.
I think it has been nicely covered. I mean, how we can promote this industry as a global industry. That's my first wish list. I mean, from my personal as well as from the industry perspective. And secondly, we say ki yes, we are the most reliable in this segment. Third is towards the ESG, I mean, compliance. Better as early we go, better it is, because it's a international requirement and plus the investors requirement. And plus the IPP side, lastly, I'll say ki whatever the support you require from IPP, like one maybe you want booking for next 3 years, so that you can book your tier 2, tier 3 suppliers well in time. You can, if we can help you to ensure the quality, what has been talked about, Sanjeev and all that, so we can help there. I am booking, I mean, at a stretch, I normally book 5 gigawatt hour, 5 gigawatt this transformers, so that it facilitates you to book your lines, your factory, your sub-ordering and all that. That's what I do. Last year also I did the same quantum. This year also I'm booking up to 28, 29, early 29. And in terms of price, in terms of value addition, value engineering, I mean, normally one of the subjects I always tell, ki our engineering department is not so competent as you are. So it's, please treat this as a requirement from point A to point B. What the best engineering solution or a solutioning exercise you can bring to us, we are there to adopt those. So that helps you as a manufacturer, as a industry standards, whatever it is, we are there to support. Thank you.
Yeah, thank you, Rajesh. And Manish Mehtaji, please, your take.
I think first of all, thank you very much for inviting and having that fruitful discussion. Most of the things have already been covered by Rajesh ji. I am very hopeful about this industry. I think we will create reliable, transparent players out of it. I am banking on this industry, and I believe that we will create global brands from this industry. So that's my take.
Before I move to you, Anirudh, there's one thing I'm just going to also touch base. ये reliability की जो बातें कर रहे हैं, अभी sir mentioned about the current density, right? We touch flux density 1.7. वो जो दूसरा decimal बोलते नहीं है, वो 1.71 से 1779 भी होता है. So I think let's be transparent now. It's time you should define your role. That if I'm giving a flux density or a current density or an impedance, I stand to the molecular decimal and I prove it on the transparency. Your final take, sir.
Yeah. So as most of the eminent speakers mentioned, the kind of ambitious goal we have, on achieving from the renewable sources. Considering the asking rate what we have, transformer, I believe historically, engineered to order product is no more, applicable in today's, world of high asking, rates. And this is where, together, the standardization is the only key, which I also feel, because it cannot happen that 250 MVA for, one buyer is having different impedance compared to, buyer 2. And, when we have more of standardization, in terms of, interchangeability, that gives a lot of ease, because there will be only few ratings, as Goel Saab mentioned, for particular solar park, and that will give a lot of flexibilities and ease, to the manufacturers also when it comes to faster execution. Because what I feel and what I see in coming 5-6 years is the execution will be the key, wherein while you have your designs in place, execution and how fast you deliver the product is going to be making a big difference in order to achieve the goals. And this is where, sir, we as an industry will be seeking your support, forming, standardizing all the transformer ratings, be it IDT, be it large power pooling station transformers. Because this also helps, I believe, in site activities, because many times, it is mentioned that, the foundations for make A was made, but, that supplier is, is unable to give. So, some other transformer is being diverted, so there will be some changes to be made in the foundation. So if we have, why can't we have standard foundations? Irrespective of any makes, the foundations can be made ready, the firewalls can be made ready, so that will be a kind of plug and play solution, which together, with, your support we can always achieve. So let's aim, sir, to go for more of, standardization, what we have seen in China and, America and, Australian market, to achieve, this ambitious goal of 500 gigawatt plus by year 2030. Thank you.
Thank you so much. And before I, take up the questions, from the audience, if anybody would like to, just to our eminent, please. Aji, please, aye. Oh my God, sir, aye, sir, please. We will just take 3, because we are, closing on the time. You have 5 minutes, so, okay, ठीक है, okay, fine. Sir, you just have a minute. 5 minutes, no? नहीं 1 minute, बाकी लोगों को भी पूछना है. आइए sir, आइए, please. Most welcome.
Good morning. Actually, industry has been benefited by my experience. You may not be knowing me, but you have met me once also. Oh my God. Yeah. I am the person who started this standardization, which you are talking throughout the year. 2016 it started. Prior to that, it was not there. The transformer manual of CEA. Now, since the time has passed, so I am going to support you from this dais. That's why I have come here.
Sir, आपका time allowed है, जितना मर्जी आप बोलिए आप. पूरा अभी आप 5 मिनट पूरा लीजिए. I will close.
सिर्फ 5 में हो जाएगा और पॉइंट्स में बोलूंगा, ज्यादा नहीं बोलूंगा.
ठीक है जी.
उसको पेपर
Thank you sir. Thank you sir.
तो देखिए, हिंदी और इंग्लिश मिक्स रहेगा, जिससे कि जय भारत भी होता रहे बीच बीच में. बेसिकली क्या है, जो ट्रांसफॉर्मर का स्टैंडर्डाइजेशन था बहुत समय से पड़ा हुआ था. 2016 में ये दिया गया काम मेरे को. फिर मेरे जो और सीनियर्स भी थे और भी थे, दूसरे काम दे दिए गए मेरे को. तो ये सब किया, हम लोगों ने निकाला. उसकी अच्छी तारीफ हुई, अच्छा चल रहा है. उसमें हमने रखा क्वालिटी और इंटरचेंजेबिलिटी और जो फाउंडेशन वाला है और एसेसरीज का भी, कि जो नए ट्रांसफॉर्मर्स आएंगे ये फाउंडेशन लगी हुई है तो इस फाउंडेशन पे बैठ जाएगा, फेल हो गया तो कहाँ से लाएंगे, हम अपने दूसरे भाई से ले लेंगे, सीमेंस का है, हिताची का है, बीएचईएल का है, वी विल टेक दैट एफर्ट हैज बीन डन. If somebody reads that big volume, it's already there. Similar thing done for that in 2021 for the solar transformers. Solar transformer also lot of thing has been done, but since the industry was say not so mature at that time, and also the participation from the industry was also less. That will be very blunt. ठीक है, तो आया नहीं. Only some of the things which some knowledgeable person knows have come in. It's time now, it's a continuous journey, you daily require new dish. Similarly, daily and on seasonal basis, you require the new things to be done, new designs to be done, and as Sanjeev ji told, that many things are being developed. My request, and I have been, those who have come to me either singly or in a group, I have advised that you compile your solutions, your problems, reach to the appropriate forum. These we are limited only 100 persons. किसी को नहीं सुनेगा, कोई यहाँ डिसीजन मेकर नहीं है. मैं भी अब डिसीजन मेकिंग में नहीं हूँ, मैं अब सीए में नहीं हूँ, फॉर योर इन्फॉर्मेशन, रिटायर हो गया हूँ. ठीक है, तो ये आप करिए. आई कैन गाइड कहाँ करना, क्या करना. डीपीआईटी से हमने बहुत कुछ किया, मिनिस्ट्री ऑफ कॉमर्स से बहुत कुछ किया, मिनिस्ट्री ऑफ स्टील, बीआईएस. जो स्टील की बात कर रहे हैं, प्राइम ग्रेड स्टील की, 8 साल झगड़े के बाद क्वालिटी कंट्रोल ऑर्डर आया था. एवरीबडी नोज, वो लोग अब इंडस्ट्री में है भी नहीं. तो ये चीज़ें हैं, ये करनी पड़ेंगी. रही बात सप्लाई चेन की, अभी पुतिन साहब आए थे, पता नहीं क्या क्या बातें हुई हैं. आप लोगों की इंडस्ट्री मीट होती है हायर लेवल पे. मैं पुराने मंत्री जी साहब से कहता चला आ रहा हूँ कि जब पुतिन जी आए या आजो सिम्बे आजो तो चले गए, ठीक है, उनको भी कहता था कि उनसे जो है थोड़ा साठगांठ करके सही से करके निप्पॉन की फैक्ट्री एक यहाँ लगवा दीजिए. लगनी नहीं है. ठीक है. दूसरा क्या है, जो ट्रांसपोर्ट वाली इशू है, 200 किलोमीटर 2 दिन वहां जाने में लगते. डू यू फील द वेरी गुड हाईवे इज देयर? गड्ढे में ट्रांसफॉर्मर गिरेगा आपका तो उसकी क्या हालत हो जाएगी, उसकी तो सारी कोर ही डिस्प्लेस हो जाएगी. और उसको जाके आपको विद इन टाइम लिमिट्स लगाना है. विद इन टाइम लिमिट्स लगाना है तो कौन वहां साइट पे चेक कर पाएगा उसकी कोर का अलाइनमेंट. ये वाली चीजें हैं. पानी वहां है नहीं, कूलिंग की व्यवस्था है नहीं, फायर फाइटिंग की व्यवस्था लगाई नहीं है. तो फायर फाइटिंग की व्यवस्था के लिए क्या किया गया कि वाटर मिस्ट, हाई वेलोसिटी एंड लो वेलोसिटी वाटर मिस्ट सिस्टम, क्योंकि स्प्रिंकलर सिस्टम काम नहीं कर सकता है. फिर दूसरा क्या है, उसके साथ एक प्रोटेक्टिव डिवाइस लगाना पड़ेगा, नाइट्रोजन इंजेक्शन फायर प्रिवेंशन सिस्टम. सीए सेफ्टी रेगुलेशंस, कंस्ट्रक्शन रेगुलेशन से हमने चेंज किया. सीए सेफ्टी रेगुलेशंस 2023 8 जून वी ब्रॉट इन एट वन प्लेस. 46(9) regulation says automatic fire prevention system should be there. How you are complying? There is no standard. उसमें 3 वर्ड जोड़े गए, एज पर रेलिवेंट स्टैंडर्ड. वेर इज द रेलिवेंट स्टैंडर्ड फॉर NIFPS? If the relevant standard is not there, I am surprised how you are claiming and how the inspectors are doing their justice that their things are being complied with. 10 MVA के ऊपर जो भी transformers and reactors will be there, they have to be provided by not any specific name but the automatic fire fighting system as per relevant standard. So this is the role of the standardization where it plays. Since the standard is not there, what to do? Everybody is closing their eyes and sleeping. Okay, let them sleep. Certainly I agree with the rationalizations of the ratings. We should not say this one, that standardization is standardization. Actually standardization का basic है, it helps everyone, the supplier, the inventor, the designer, the inventory, who is maintaining the inventory, and the ultimate users, because the competition is there and the standard ratings are there. Everybody knows. Another thing is the proper consultation is not happening among yourself also. सरकारी डिपार्टमेंट्स की तो बात छोड़ ही दीजिए, उनसे तो होता ही नहीं है, उनका आपस में भी नहीं होता है, आपका भी नहीं होता है. दैट इज व्हाट द फ्रेगमेंटेड व्यूज कम्स, एंड द फ्रेगमेंटेड व्यूज कम्स इन द फॉर्म दैट दिस विल फेवर मी, दिस विल फेवर मी, दिस विल फेवर मी, आई एम नॉट गोइंग टू डू इफ आई एम ऑन द सीट. then location of the RE should be known to the designer and the planner, those who are either sitting in the STU or those who are sitting in the CEA. We do not know where the generation is, where your generation is likely to come. At least plot तो बता दो वो कितने square kilometer में आ रहा है. Where we install our transformer, where we install our line. And in line case, the ROW and the forest issue has not been touched here. I will request that somebody from IEEMA should keep on writing these things. Forest is the biggest problem. Individual, of course, will be getting benefited, and he intends to get benefited because he is giving you the land for its use. He need to be consulted. He need to be safeguarded. And what about the VESS? VESS, you are tell, VESS, the life issue is there. Otherwise, its eco-sensitive issues are also there. Be careful. Higher the automation, higher the issue of, you can say, the cyber security issues. And the designers have his own opinion and wisdoms, and he keeps on reading, so the innovation should not be killed. Interchangeability aspect I have covered. Interchangeability has to be of the bushings also and of other say cooling accessories also. CRGO and components we will keep on telling and telling, but CRGO issue need to be solved. It has to be Ministry of Commerce, Ministry of Industry and the PMO. एक दो इशू है. ROW का समस्या क्या है? ROW जहाँ पे ज़्यादा समस्या हो जाती है तो मोनोपोल अभी आ गए हैं, और हमारी जो क्रॉस आर्म्स हैं वो भी स्टील वाली नहीं होके जो दूसरी इम्प्रूव टाइप की आ गई हैं, वो भी इंसुलेटेड क्रॉस आर्म्स आ गई हैं. ट्रांसपोर्टेशन के लिए आपको जो ट्रांसपोर्ट एजेंसीज हैं वो आपकी नहीं है, वो किसी PSU की भी नहीं है, वो प्राइवेट सेक्टर में ही हैं. काइंडली बिल्ड अप देम, सपोर्ट करो, CSR से कर दो कि भाई बनाओ एक अच्छा था टेलर जिसमें कि झटके उठ के ना लगे कुछ. ठीक है, कोऑर्डिनेशन होता नहीं है, तो कोऑर्डिनेशन इज लैकिंग. एंड why we keep on tying, we take lot of time in approval of the design and approval of the papers, and when it comes to the execution, time नहीं है, time लगाइए, आपकी limit cross हो गई है, penalty लग जाएगी and all those things. Time, working season is also another thing. When high heat and high sun are there in the deserts, and when lot of rains are there.
सर आप क्या 1 मिनट रह गया?
हाँ, तो 1 मिनट में हो जाएगा.
हाँ जी.
दूसरी बात क्या है, मैन पावर नहीं है, अकेला आदमी चना नहीं फोड़ सकता है, कितना ही अच्छा आदमी हो उसको टीम चाहिए. हमारे पास टीम नहीं है. आप जैसे लीडर तो हैं, बट आई डू नॉट नो, यू मे बी हैविंग एन एफिशिएंट टीम सर, जैसा लग रहा है. ठीक है, और वर्क इज एक्सपेंडिंग. दूसरा क्या हुआ है कि काम एकदम से आ गया है, RE हमें 500 मेगावाट गीगावाट लगाना है. RE तो लगाना है, लेकिन फैक्ट्री इतनी वजह से हुई, फैक्ट्री तो बंद होने जा रही थी. ये तो आई एम द पर्सन के जो चाइना जो बात हो रही है वो गवर्नमेंट परचेज में TVCV में चाइना फैक्टर लग गया, इसलिए हमारी जो ट्रांसफॉर्मर की इंडस्ट्री है वो रिवाइव हुई. अदरवाइज ये बंद करने जा रहे थे सब जो उधर बैठे हैं, वो कह रहे थे कि हम बंद करेंगे कब कल को. तो हमें कहा नहीं, अभी बंद मत करो, अभी डिमांड आएगी. अब देखो डिमांड इतनी आ गई कि सप्लाई नहीं कर पा रहे.
चलो सर I would like to give a big round of applause, you know, because actually this is the ये नहीं बोल रहे, ये सरकार के अंदर से ना जो इन्होंने काम किए हैं, जो गवर्नमेंट में रह के जो उन्होंने काम किए, उसी का ही आज कंफर्ट हमें मिल रहा है, और उसी का नतीजा है जो हम लोग आज बैठकर वी आर टॉकिंग ऑफ बिग स्टोरीज, वी आर टॉकिंग. बट एक चीज सर आपको मैं बिल्कुल पहले बताओ, थैंक यू वेरी मच दैट यू हैड दैट करेज टू कम फॉरवर्ड इन हियर एंड
नहीं
but
सर, वो सर्विस में भी ऐसा ही बोलते थे.
नहीं. So is there anybody else who would like to just one more request?
Thank
Please.
you. Let the other guests.
I just want to clarify one point on behalf of IEEMA, that this is a subject which is very dear to us and very important subject also. So this was just the teaser. We are going to plan one full day session on this, where everybody will be invited to come together and find a solution, because what we need to do is to find solution and implement it faster. राजपूत साहब, आपको 1 मिनट सिर्फ इसलिए दिया गया था because you are a man of action, not of words. So we thought कि 1 मिनट में सब कुछ हो जाएगा. My apology on that.
Yeah, no, thank you Imtiaz Bhai. And I think for me in personal, it has been so inspiring and it has been so motivating, to sit with such an eminent, and her take as a company, we've also, touched about 10 gigawatt of, grid evacuation in the renewable space. And today, having spent time with them, I think we are equally motivated, to be part of the glory and the success of power in the renewable sector where we all belong. So once again, thank you so much. Each one of you, and you really made it very energetic and very, very, I think, to the point. And each one of you, thank you so much. Over to you, ma'am.
Thank you. Thank you, sir. Thank you for such an impactful session. Surely we have kept the best for the last. Now, I would request Mr. Anand Sharma to please felicitate our panelists. To Mr. Manish Mehta. Can we have a round of applause, please? To Mr. Sanjeev Pushkarna. To Mr. Rajesh Goyal. To Mr. Anirudh Jhala. And to felicitate the moderator, I would request Mr. R. Prakash. You can change it. Change. Mr. R. Prakash also to please join. Thank you, sir. I would request everyone for a group photograph. Thank you everyone. Now for the valedictory session, we are starting with the Best Paper Award, for which I think everyone has been waiting for. And for that, I would request Mr. Vikrant Joshi, Chair Technical Committee, to please be on the dais, along with Mr. Ramachandran, Mr. G.J. Kulkarni, Mr. Y.V. Joshi, and Mr. Potnes, to felicitate the Best Paper Award. Over to you, Joshi sir, for making the announcement of the best paper. Yes, sir. Vikrant Joshi sir, yeah.
So, good morning everyone. So we have had very exciting and intense technical discussions over the last 2 days. During the 6 technical sessions that we had on Thursday and on Friday, it provided us very relevant, very latest and quite practical insights. And now is the time to award the best papers. Honestly, was very difficult to rank the papers because they were all really very high quality papers. There were only very thin differentiation between the papers. All the same, thanks to the jury committee consisting of Mr. Ramachandran, Mr. Y.V. Joshi, Mr. Potnis, the entire session chairman and session co-chair, all these people helped rank them, and I think so we had to give 3 awards, but the papers were so good, we had to settle on 2 papers each for the 3rd position as well as the 2nd position, and of course the first award is the first award for a single paper. Yeah. So now I have the privilege of declaring the awards, which I will start now. I will start with the 3rd position. Yeah. So the 3rd position is for 2 papers, and the paper which is from session number 2, Innovation and Futuristic Trends in the Industry, Futuristic Transformers for 2030. And the paper name is AI Driven Transformers, Revolutionizing the Life Cycle of Power Transformers, and the author is Saravanan. He is the Technology Center Manager of Hitachi Energy. Congratulations, Saravanan. The next 3rd award, which is for the 3rd position again, it is from session number 6, Emerging Trends in Transformer Input Materials and Accessories. The paper is Intelligent Thermal Protection for Dry Type Transformer, and the author is Ketan Sanjay Jadhav, Lead Engineer, Tata Power, Mumbai. Yeah? Okay. Now I will declare the runners-up positions. Again, as I said, there are 2 runners-up positions we have considered, and this award goes to session number 1, Sustainability and Reliability through New Solutions. The name of the paper is Online Monitoring Systems for Performance Optimization and Predictive Maintenance of Power Transformers by Shubhayan Mukherjee from CESC. One more runners-up position is from session number 5, Reliable O&M Practices and Life Cycle Management as well as Transportation. The name of the paper is Digitalization in Power Transformer Operations, Impact on Efficiency and Predictive Maintenance by Atul Pandeji, Specialist Professional from Hitachi Energy again. And now hold your breath for the top position. The first prize And the first prize is from the paper in session number 3, the best practices in transformer design and manufacturing. The name of the paper is An Insight into Mechanical Stresses in Core and Windings of Power Transformers. And the author is Mr. N. Maheshwara Rao from CPRI, Bangalore. So, all the awardees and all of us, let's join for a group photograph before we disperse.
Requesting Charu ma'am to also join, please. Charu ma'am.
So, this is the technical committee who did a wonderful work of selection of all the papers, scrutinizing these papers, and in making these sessions in the final form. I thank all of them for their contributions. Thank you very much, technical committee.
Thank you very much. Keep it up. Yeah, good job.
नहीं 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 Thank you and congratulations to all the winners. Now to felicitate our sponsors and committee members, I would request Ms. Charu Mathur, DG IEEMA, along with Mr. R. Prakash, Mr. Imtiyaz Siddiqui and Mr. Anand Sharma to felicitate our sponsors. I would request representatives from the following organization to please be on the dais. Representatives from Atlanta, representatives from Atlanta to be on the dais, please. Can we have a huge round of applause for our sponsors? From transformers and rectifiers, representatives from TNR, please. From Vardhaman Stampings, can we have representatives from Vardhaman Stampings on the dais, please? Is someone from Vardhaman Stampings? If not, okay, then IEEMA tap changes. Representatives from IEEMA, please be on the stage. Representative from Amod Stampings. Representatives from CG Power. CG Power representatives, do we have? Representatives from Danish Private Limited. From Danish Private Limited. From Indotech Transformers. From Polywater, please. Polywater. From Protrial India. From Apar. From BHEL. From Dobble. From GE Vernova. Can we have a round of applause, please, from the audience? From KSH International. KSH International. From Maiden T&D. From MIM. From Parmali Wallace. From Pressy Measure. From Siemens Energy. From Star Energy. Star Energy representatives, do we have? From Toshiba T&D. From Savita Oil. Thank you to all the sponsors for their contribution and support to Trafotech Global 2025. Now I would request the advisory committee to please be on the dais. Mr. Shovik Bhattacharya, Mr. Y.V. Joshi, Mr. P. Ramachandran, Mr. R.K. Tiwari, Mr. K.R.M. Nair, Mr. Alok Agarwal, Mr. B.N.D. Bomik, Mr. Gautam to Mr. Gautam Mazumdar. Mr. Shrikant B. Potnis. Mr. Y.V. Joshi. Can we have all the advisory committee members? Mr. A.K. Rajput. Mr. Tapas Ray. Mr. M. Vijay Kumaranan. And Mr. Ajay Kumar Dhagat. Can we have a round of applause for the organizing committee? These are the brain behind this successful conference. Now I will request the technical committee members to please be on the stage. Technical committee members, Mr. Vikrant Joshi, Mr. A.S. Jhala, Mr. Manish Yadav, Mr. K. Vijayan, Mr. Ankur Pathak, Miss Mr. Gunjan Agarwal, Mr. C. Jayasenan, Ms. Tanvi Srivastav, Mr. Rajendra Prasad, Mr. Sarvanan S, Mr. Akshay Dave, and Mr. Nagarjuna Babu. Thank you. And now to the organizing committee members. Can we have a huge round of applause for Mr. Ruche Mayank, Mr. Purushottaman M, Mr. Anand Sharma, Mr. Imtiyaz Siddiqui, Mr. R. Prakash, Ms. Aruna Janardhan, Mr. Mihir Merchant, Mr. Neeraj Yadav, Mr. Keyur Shah, Mr. Amandeep Singh, Mr. Shivam Talwar, Mr. Sudhir, Mr. Rajaram Shinde, Mr. Satyan Mamtora, Mr. S.K. Jain, Mr. Hartik Singh, Mr. Rajiv Chaudhary, and Mr. Sridhar Gokhale. Can we have a round of applause for the organizing committee, please? A round of applause for our organizing committee. Can we have all the IEEMA IoTs on stage, please? All IEEMA IoTs.
Those who are going to stand in election with mobile phone as their symbol, request you to keep the mobile phone for a minute and come onto the stage.
IoTs are the unsung heroes and heroines of this show. Please give them a round of applause for them, please.
Now to conclude this conference, I would invite Mr. Imtiaz Siddiqui to give the vote of thanks, please.
Good afternoon, everyone. Are we happy after 2.5 days of rigorous time that we have spent here? So this is customary to give vote of thanks. So, but I always speaks from my heart. So first of all, the big applause and thank you for all of you who came in large number, in spite of the fact that there were some travel issues due to the cancellation of multiple flights by Indigo. We had such a large audience here, and who has been together with us and listening to all the papers and keynote speeches delivered by the stalwarts of our industry. Whenever I sit with Mr. Ramchandran, I get to know information which I would always like to share with you guys. So I was told that this Trafotech was started in 1982 by a visionary leader. His name was Mr. K.G. Session. He was the managing director of TELC at that point of time. And I could see one or two, I think 2 delegates from KSEB here. So what started in 1982, we are still continuing in 2025, and we hope that in 2027 we all will be again together for the next edition of Trafotech Global. I would like to thank the advisory committee members. I would not take the names because we were all here and we felicitated them. But without their guidance, we would not have been able to put in this kind of program together. They have always been very kind to us, to guide us and give us the direction and help us whenever and wherever we were stuck. Thanks to the technical committee and their, untiring efforts, that we were able to select the 36 or 37 papers that have been presented out of hundreds of papers that they received, and they have gone through and evaluated, and we got to have the best papers that has been presented here, and some of the papers have also been included in the IEEMA journal. My big thank you also to my fellow organizing committee members. I still remember for last 15 days our family has forgotten us. 8:30 for me in Dubai and 10 p.m. for all of them who are here in India time. And we used to have the stock of things. A big shout out for IEEMA IoT team. So basically, what we get to see in an event of this magnitude is remain under preparation for many, many days. And many times we come across so many challenges, we have to find solutions, etc., etc. But at the end of the day, like, we say that in Indian culture, when you marry your daughter and when she is, sent to her in-laws' home, the parents of the girl side or the relatives of the girl side feel very, very, relaxed. So I can see from the faces of my friends that we are now fully relaxed, that whatever we have been preparing for, we are able to deliver it. You have to tell us whether we have done it in the right way or not. Your feedbacks are always solicited, because whatever feedback you will give us will help us in organizing the next program in a much, much better way. So in the end, I invite all of you to have lunch with us at Assembly Dining Hall. So please join us for the lunch, and then this brings us to the end of Trafotech Global 2025. And as I always say, मेहरबान होके बुला लो जब भी चाहो मुझको, मैं गया वक्त नहीं हूं कि फिर आ भी न सकूं. So see you guys in 2027 Trafotech Global again. Thank you.
Power. It drives progress, connects industries, and shapes the future. As the energy landscape shifts from conventional fuels to green alternatives, Atlanta Electricals is at the forefront, ensuring stability today while enabling the transition to a sustainable tomorrow. At Atlanta, we don't just build transformers, we strengthen the
At dawn, the world wakes up to new possibilities. Streets hum, dreams take flight, and progress reaches new heights. A quiet force drives it all. CG Power and Industrial Solutions Limited, an engineering
Powering progress, lighting lives, and shaping the future.
In a world where energy drives progress and shapes the future, Indotech Transformers stands out for its unwavering commitment to powering your world with reliable, sustainable transformers.
Ever since our foundation in 1910, focusing on the fields of automobile, industrial infrastructure, and electronics, Proterial has produced materials of exceptional quality. Supported by our advanced technology and development capabilities, our tool steels and magnetic materials and power electronics materials with excellent properties have all realized improved productivity and efficiency for xEVs.
Power. It drives progress, connects industries, and shapes the future. As the energy landscape shifts from conventional fuels to green alternatives, Atlanta Electricals is at the forefront, ensuring stability today while enabling the transition to a sustainable tomorrow. At Atlanta, we don't just build transformers, we strengthen the backbone of a reliable, evolving power grid. From solar and wind to conventional power, our transformers ensure seamless transmission across industries and communities, helping shape a smarter, cleaner, and more resilient energy future. For decades, Atlanta Electricals has been at the heart of power transformation, ensuring industries, infrastructure, and transmission networks run without disruption. With a presence across 19 states and 3 union territories in India, we have installed over 78,000 MVA and more than 4,000 units, while steadily expanding into global markets. At the core of our operations is a manufacturing ecosystem built for precision and scale. With 5 advanced production facilities, we are equipped to meet the evolving demands of modern energy infrastructure. Every transformer we make is designed to last longer and perform better. Our diverse transformer range supports critical sectors nationwide, from power transformers to furnace transformers and special duty units to inverter duty transformers. We have solutions for all customer needs. We also power transportation through trackside railway transformers, and our green ester oil transformers offer a sustainable, safer and longer lasting solution. India is moving towards its vision of becoming a developed economy by 2047. And Atlanta Electricals is not just keeping pace. We are thinking ahead. As we move toward a brighter, greener future, Atlanta remains committed to powering progress and transforming lives. Together, we will build the energy systems of